For our next App Inventor SQLite database project, we're going to edit content and update the SQLite database. The SQLite file, called glutenfreecookery.sqlite, holds the HTML text of a cookery book. The .aia files and the .apk files for this project are available as an app which downloads the files to your SD card when it is first run. You can then copy those files to the computer that you use to work with App Inventor. The AIA files are zip files, and you can extract all the assets files from that. The gluten-free cookery SQLite file has a slightly more complex structure than the ComTrade data in the previous tutorial. This time we have two tables. Browsing the data for the table Book Data shows two rows of data about the books in this database. Browsing the table Book Pages shows one record for each page. Each page is identified by its page name and the book. Each page has a page order in its book. The data elements for the page content and the page heading are more than just a few words of text. The full contents of this cell can be displayed on the right by selecting the cell. A single cell contains the full text of that page with its HTML formatting. The database structure information gives us the type for each column. Again, most columns have the type text. The page order uses the type real, as we're using this to sort pages into their order in the book. Two columns store dates, and we are using the type datetime for these, although we could use text. We will start a new project in App Inventor and call it Working with SQLite Gluten-Free. Then we will upload our gluten-free cookery.sqlite database file as an asset. Again, the blocks that we need to work with SQLite are not part of the core blocks, so we need to add these as an extension. We will use the org.benedum.sqlite.aix extension, which we downloaded to our computer, and then we upload it to our project. For the user interface, we will use list views to select the book and the page. When a page is selected, these list views will be hidden and we will display the selected page. Initially, we will display the selected page in a label set to display HTML, but this would not be editable. We will also display the page in a text box, but although the text would be editable, what we would see would be the raw HTML and not a nicely formatted page. So that the user doesn't have to remember to press a Save button after editing, we will automatically save the content of the text box if the text box gains focus and then loses focus. But note that a text box doesn't automatically lose focus if the user clicks another button. We can, however, force it to lose focus by moving the focus to a tiny text box whenever the user clicks a button. If we want the user to see nicely formatted HTML content and to be able to edit that content, then the solution is to display our page using a WebViewer, where the content is displayed as nicely formatted HTML and can be edited and sent back to the database. However, before we develop the WebViewer display, we will develop all the blocks needed to select and display pages using a label and edit with a text box. The process to display and edit a page in our cookery book is as follows. When we initialize the screen, we hide all user interface options except for the list view book component. We import our // glutenfree cookery.sqlite database from the assets folder. We open the database. Then we populate the set list view book elements component with a list of books from the database using the SQLite select SQL component. The SQL query is select distinct book title from book data. And since we are not using any parameters, the bind params is an empty list. The user can now use list view to select the book to open. The component when list view book.afterpicking is used to populate set list view page elements. But we don't populate this directly from the database. We want to display the heading for each page in the list view, but then use the page name of the page in subsequent requests to the database. We also want to use the book in our queries rather than the book title. First, we will create a list that contains just the selected book, then a list that contains all page name in the book, then a list that contains all page heading in this book. Note, if I were programming using a language like Python, we would extract all these properties with a single query, but with App Inventor, it is much easier to use 3 separate queries to create 3 simple lists. The first query to set the global list book list uses the SQL query select distinct book from book data where book title equals ? The parameter here is a list containing the book heading we have picked from list view book. The next query sets the global list page name list using the SQL query select page name from book pages where book equals ? Order by page order ASC. ASC stands for ascending. The parameter here is the book, which is already a list in global book list. The third query sets the global list page heading list and uses the SQL query select page heading from book pages where book equals ? Order by page order ASC. The parameter here is the book, which is already a list in the global book list. We can now populate set list view page elements with our page heading list. When the user uses list view page to select the page, we use the component when list view.afterpicking to display the selected page. This time we will set another variable, global page index, using the index value from list view page select index. This page index value matches the lists we created previously for all pages in the book. Now we use the function to call display page. In this function, we want to hide both list views. We already have the heading of that page in our list of page headings, and we know the index for the heading we want is stored in the global page index variable. We can insert that page heading into our label page heading. We don't yet have the content of this page, so we need to extract it from the database using the SQL query select page content from book pages where book equals question and page name equals question. For the parameters, the book is the first item in our list global book list, and the page name is in our global list page name list at the index identified by the value page index. Since the output from the query is a list with a single item, we need the item from the list at position 1 to add to our page content label. We display the previous and next buttons except if the page we are looking at is the first or last page in the book. The previous button, when clicked, sets the page index to 1 less than it was before and calls the function display page. The next button, when clicked, sets the page index to 1 more than it was before and calls the function display page. Now that we have completed these blocks and tested our app using the non-editable label for the display, we need to see what needs to be changed to make each page and page heading editable. To edit the content, we need a text box for the page heading and a text box for the page content. We can place these in our design alongside the labels used to display the same content, and we can add the same content, but simply not display these text boxes until the user clicks on the Edit button. When they want to edit a page, we hide the labels displaying the formatted HTML content and display the text boxes displaying the raw content for the page. The user can now edit the content. Any text box has the actions got focus and lost focus. We can use got focus to change the background color to indicate which text box is being edited. We can use the action lost focus to start the process of saving the edited content of that text box and to change the background color of that text box back to indicate that it has been saved. However, if the user moves from editing to press another button, focus remains in the text box and the content wouldn't be saved. We have to make sure that pressing any other button removes focus from the edited text box. We do that by first moving the focus to another hidden text box, which we will call Focus Box. Since there are several buttons that the user might click next, we can use a procedure to reset the focus called Reset Focus. The procedure Reset Focus switches Focus Box Visible to false, then back to true, then calls the Focus Box Request Focus. This makes our edited text box lose focus and call the component when Content Editor lost focus or when Heading Editor lost focus. In both cases, we can reset the background color of the text box and then save the edited content back to the database. We use the SQLite 1 execute component. The SQL code is update book pages, set page content equals question mark, where book equals question mark, and page name equals question mark. Update book pages means that book pages is the table in the database to be updated. Set page content equals question mark. Set is the instruction to update this column, which is page content, with the value of the first parameter. Where book equals question and page name equals question mark identifies the values of the book column and page name column where the page content should be updated. The question marks give the values for these as the second and third parameters. We provide the parameters in the form of a list that matches the order of the parameters in the query. The first parameter is the edited content from our text box, content editor.text. The second parameter is the book, the first item in the global book list. The third parameter is the page name, which we identify from the item in the page name list at the index position page index. Saving the edited page heading follows exactly the same sequence of actions. We follow this by updating the page heading list so that if the page heading has been edited, the new heading is displayed in list view page. Now, the main problem with this example so far is that the user is expected to edit raw HTML. We can avoid that by using a WebViewer. WebViewer displays the content as a web page using HTML and CSS, and we can use this to both display and to edit the page as well formatted text. Other App Inventor blocks send data to this web page using the set WebViewer.WebViewString to block and can read data back when JavaScript in the web page also changes the value of the WebViewer WebViewString using window.appinventor.setWebViewString, and that is followed by the edit data. The process to display and edit a page in our cookery book is as follows. Use list view to select the book. Use list view to select the page. Get the page content from the database. And those three steps are exactly the same as we've programmed and tested previously. Instead of using a label to display the content, we set the content of set WebViewer WebViewString to the content of the page. JavaScript collects the content of the WebViewString page and sets a variable page text to equal window.appinventor.getWebViewString. JavaScript places the page text in an editable div to display it. If the user edits the page text, JavaScript copies the edited text back to the WebViewString with window App Inventor set WebViewString and a variable which will be the edited page text. The App Inventor blocks detect that the WebViewString has changed and saves the changed data back to the database. Now we need to establish the protocols that we will use to communicate between the App Inventor blocks and the JavaScript within the WebViewer. I'm going to use double tilde characters to separate the elements in a string of text. Later I will also use the not symbol. If your user will edit content that uses these symbols, you would have to use different symbols as text separators. But they would not often be used as pairs like this. So the first string is send, double tilde, page heading, double tilde, content of page. And from the JavaScript back to the App Inventor blocks, reply, double tilde, page heading, double tilde, edit content of page heading, or reply, double tilde, page content, edited content of page. We modify the function display page so that instead of writing the page content to a couple of labels, we write the content to WebViewer1.WebViewString, joining the text strings, send, page heading, content of page. We also need to rewrite our function to save any edited data. Edited data is sent back from the WebViewer, so we need to process this whenever it changes using when WebViewer1 WebViewString change, which places the content in the local variable value. When we are developing a program that uses the WebViewer, it can be useful to display the content of value in a label. Usually displaying the first 100 characters is enough for us to see what is happening, and this first section of code displays the first 100 characters without producing an error if it is less than 100 characters. In this app, there are two messages that we want to save. One that starts with reply page heading and one that starts with reply page content These headings need to be removed, and then the procedure to save the edited page heading or page content is exactly the same as we used before from the edited text box. The code for the WebViewer is an HTML page with some CSS and some JavaScript that we upload to the assets folder. We will call this HTML page webpage.html. The home page for the WebViewer needs to be set to this file, and again, as I'm using Genymotion emulator, it's the actual APK version that I use, file followed by slashes Android asset /webpage.html. If you haven't used HTML, CSS and JavaScript before, have a look at my tutorials that introduce these topics. This page will also use some JavaScript code known as jQuery, and we will upload the jQuery files to the assets folder. These are jQuery.min.js and jQueryUI.js. I will now go through the complete code of webpage.html. It starts with the standard headers for HTML5. So we see the doc type declaration, the language declaration, the character set declaration, viewport, and I've set this to no cache, which you want to do if you are testing it on a desktop computer first. I've styled two elements here, but you could style more. The div with ID save data is styled so that it always displayed at the top of the page on the screen. The rest of the page will scroll. For that, we're using identifying the ID save data, giving it a position fixed and top of 0, background color of yellow, and border radius. The div with the ID page heading is styled to make it stand out, using background color, font weight of bold. That's the end of the styles that I've set. We then have the normal start of the HTML body, the div for saving data, and this is followed with a div with an ID of page display. Next are two divs, the first with the ID of page heading and the next with the ID of page content. Both of these divs are given the class divEdit and have content editable set to true. This makes the content of both of these divs editable. The class divEdit is used by the code that collects the edited content. And that is all the HTML content of this page. The rest is inserted by JavaScript dynamically as the app is used. We need to load both jQuery files, which we'll add next, loading the scripts with sources jQuery.min.js and the script with source jQuery-UI.js. These are local in the assets folder. That means that this app will work offline. Then we have the main JavaScript that does all the work on this page. Our script needs to know if the App Inventor block has been sent a new message using WebView string, but unlike the blocks in App Inventor, which can call a function when it changes, JavaScript has to keep checking every second. We can set an interval and use it to call the function checkMessages. So the function set interval checkMessages 1000. Once this is set to run, this will call checkMessages every second. The function checkMessages checks first to see if there is any message, to avoid an error if it tries to read a message that doesn't exist. Then it checks that the message starts with the send double tilde characters that we are using to identify these messages. If it matches this message, it resets the value of setWebViewString and calls the function to decode the page data in the message. Decoding the message is done by splitting the string at the pair of tilde characters. The first item in this array in JavaScript is position 0, and this would hold the value send. Position 1 holds our page heading, and position 2 holds the page content. We now empty the element with an ID of page heading and insert the contents of the variable page heading. And empty the element with an ID of page content and insert the contents of the variable page content. Window scroll to 00 ensures that the user sees the top of the page after new content is loaded. The user can now read the content displayed as formatted HTML, and they can edit that content if they wish. If either of these editable divs gains focus by the user editing the content and then loses focus, the content will be saved by the following function. Clicking any button outside the WebViewer on the app won't change the focus inside the WebViewer. To simplify this app, we give the user a button to click inside the WebViewer to save edited content. div.divEdit focus out function event means that a div with the class of divEdit is set to the ID of the div that is being edited. So our variable div ID is now identifies the edited div. We can then read data from the div to see if this page heading or page content. This isn't actually needed here, but useful if there are lots of different editable divs on the page. Our variable column is then set to the attribute that we wrote into the data. If the column is equal to the page heading, we can then read the content of the div that has just lost focus and set this to our page data and create our reply string. We do this by adding a string of text, reply, double tilde, page heading, double tilde, to the variable page data. If the column is page content, we get the page data from our page content div, and our reply string will be the string reply, double tilde, page content, double tilde, plus the variable page data. We then set the WebView string to be our reply string. Our App Inventor blocks now detect the change in the WebView string and save the data in the same way as we discussed earlier. We still have a problem with our combination of WebViewer and App Inventor buttons, in that we have to find a way of detecting when the user moves from the App Inventor part of the screen to the WebViewer part of the screen and then back to the App Inventor part of the screen. It's much easier to just use a WebViewer for the full user interface. The next app tutorial will demonstrate how an app can create and use a new SQLite database, and the user interface will be programmed entirely as a WebViewer.